Hi class, in lesson 6.3 we will be determining the percent of a number. The learning targets for 6.3, determining the percent of a number and using double number lines. Let's take a look at problem 1 on page 418. There is more than one way that we can determine the percent of a number, and that's what we are going to look at to start off problem 1 today. Mr. Goodwin, the 6th grade math teacher, asked the class to determine 25% of 44. So that's what we are looking at. 5 different student responses are shown. So we are going to look over each of these students' responses and analyze how each of them are correct. And again, there are different ways that you can go about determining the percent of a number. It's going to be up to you to decide which way you like best. So let's take a look at Kendra's method first. She said that I used the multiplication by a fraction method. 25% is equal to 25 hundredths, which is equal to 1/4. Then she multiplied 1/4 times 44 to get 11. Her method is going to be the most efficient to use when the percents can be easily converted to fractions. If you take a look at Hank, Hank is saying that he likes decimals much better than fractions. So he knows that 25% is equal to 25 hundredths. He multiplies that by 44 to get 11. Hank's method is probably going to be the most efficient really in any situation. If you do choose to use Hank's method, you obviously will be able to use a calculator. Ryan says that 25% is easy to do in my head. 50% of 44 is 22. 25% is half of 50%. So 25% of 44 is half of 22, which is equal to 11. Ryan's method is going to be the most efficient to use when the percents can be converted to fractions like a 1/2 or a 1/4. Simon says, since 25% is the same as 1/4, I just divided by 4. 44 divided by 4 is going to give me 11. Simon's method is going to be the most efficient to use when the percent can be written as a unit fraction. Remember, unit fractions have a numerator of 1. Pamela prefers to use the benchmarks of 10% and 5%. So much like we talked about back in 6.1, benchmark percents. 10% of 44 is 4.4. 20% is 2 times 10%. So 2 times 4.4 would give her 8.8. 5% is half of 10% to give you 2.2. If you add 8.8 and 2.2 together, you are going to get 11. Pamela's method is going to be the most efficient to use when the percent is going to be a multiple of 5% or 10%. So again, 5 different methods from these 5 students in terms of determining the percent of a number. Now it's your choice. It's up to you as far as which one you think is the most efficient and the one that you want to use moving forward. Let's skip over to number 4 on page 421. It says determine the percent for each by using your preferred method. So thinking back to everything that we just talked about with those 5 students, go ahead and do letter A through I with your group members. Let's take a look at what you came up with for letters A through I. I chose Hank's method. I feel that that is the most efficient. I'm going to take each of my percents and turn them into decimals and multiply, carry out the multiplication. So if you take a look at letter A, 7%, I write that as a decimal, 0.07, multiply that by 80, and get 5 6/10 for my answer. Letter B, I do the same thing, 15%, 0.15 as a decimal, multiply that by 55 to get 8 and 25 hundredths for my answer. C through I is carried out the same way. I'll just read over the answers. 38 and 4/10, D 24, E 180, F 44 and 4/10, G 139 and 2/10, H 40 and 5/10, and I is 8. Let's take a look at number 5 at the bottom of page 421. It says, you are the coach of the Gators basketball team. The Gators are playing the Crocs. The game is tied 64-64 with time running out. Just before the buzzer sounds, the Crocs coach illegally steps out onto the floor while play is taking place. This results in a penalty and a free throw shot for the Gators. You have to pick a Gators player to shoot the free throw. If the player makes the shot, the Gators win. You can choose one of the 4 players to shoot the free throws. During the past few games, Natalie made 17 out of 25 free throws, Angela 15 out of 20, Casey 7 out of 10, and Aaron made 37 out of 50 free throws. You want to select the player who is most likely to make the shot. Which player should you choose? Use mathematical reasoning and the data on the player's performance in the last few games to explain your choice. So go ahead and do that with your group members for number 5. If you take a look at the answers to number 5, Natalie 68%, Angela 75%, Casey 70%, and Aaron 74%. So based off of the past performance, we should choose Angela because she has made 75% of her free throws. She has the highest percentage. She has the best chance to make that shot to win the game. Now, in order to figure out these answers, you could have gone through and used 2 different methods. And these are methods that we talked about back in 6.1. You could have used your scaling up factors. All of these denominators, 25, 20, 10, and 50, are factors of 100. So you could have scaled up to easily figure out what those percentages were. You could have also just used division and used your calculator. 17 divided by 5 gives me, 17 divided by 25 gives me 0.68 on the calculator, which we know is 68%. 15 divided by 20 gives me 0.75 on the calculator, which is 75%. So either of those 2 methods are going to get you to your answer of Angela having the best free throw percentage. Let's move on to problem 2 on page 422, giving back to the community. It says, this school year, students were asked to volunteer for a service project to help in the community. The results of the questionnaire that was given to the 6th grade students are shown in the table. 300 students returned the questionnaire, with each student choosing one service project. Now, before we move on and answer all of the parts for number 1, let's make sure we understand the different parts that make up the table. Remember, we have 300 total students. So if we look at the food bank, we have 42 boys and 48 girls. That's going to give me 90. For the soup kitchen, 40 and 48 is going to give me 88. And for the senior center, 28 plus the 94 is going to give me 122. When I add all of those together, I get my total of 300. For the total number of boys that were in the survey for the food bank, the soup kitchen, and the senior center, if I add 42, 40, and 28 all together, I get 110 for the total number of boys. If I add the girls column up, 48, 48, and 94, I get 190. And if I add those 2 together, I would get 300 again. So some important information based off of the questions that you are going to have to answer now for number 1. So let's take a look at that. So number 1 asks us to explain each statement mathematically using your knowledge of fractions, decimals, and percents. I want to go over letter A with you so that you can see how to set up each of the questions to justify and explain the statements, and then I'm going to have you finish up letter B through letter H on page 423. So let's take a look at letter A first. So letter A says 30% of the students prefer working at the food bank. So if we look at the food bank, we have 42 boys, we have 48 girls. If we add them together, we get 90 total students that prefer working at the food bank out of the 300 total that we have. That ends up giving me my 30% that they're talking about back in the question. Right here, figuring out 30% of the students that prefer working at the food bank. So that is how you need to use the table and all of the information in the table to answer the rest of the questions for number 1. So go ahead and do letter B through letter H on page 423. If we take a look at letter B, about 30% of the students prefer working at the soup kitchen. If I take 40 plus 48, I get 88 out of 300. That is going to give me right around 30%. And letter C, about 40% of the students prefer working at the senior center. 28 plus the 94, that's going to give me 122 out of 300, which is about 40%. If we take a look at letter D at the top of page 423, about 50% of the girls prefer working at the senior center. 94 out of 190 is about 50%. Letter E, about 25% of the boys prefer working at the senior center, and about 25% of the girls prefer working at the soup kitchen. So 28 out of 110 boys and 48 out of 190 girls, both of those are about 25%. If I look at letter F, it says the boys prefer working at the food bank over the girls. I have 42 out of 110 boys, and I have 48 out of 190 girls. 42 out of 110 is greater than 48 out of 190. And I also put them into decimal form as well. 38 hundredths is equal to 42 over 110. 25 hundredths is equal to 48 over 190. If we take a look at letter G, the boys prefer working at the soup kitchen over the girls. 40 out of 110 is greater than 48 out of 190 for the girls. Again, I converted both of those into decimal form. 36 hundredths is greater than 25 hundredths. For letter H, the ratio of boys who prefer not working at the soup kitchen to total boys is 7 to 11. So in this case, you actually have to add the food bank and the senior center, 42 plus 28, to get your 70 out of the 110 total boys. So 7 out of 11 boys actually prefer working at the food bank or the senior center. Let's turn to page 424 and take a look at problem 3, percent problems. It says Carla is in charge of designing a way to keep a running total of the money raised by her homeroom for the food bank project. As of today, her homeroom has raised $240, which is 60% of their goal. Carla decided to use a double number line to record the money raised and the percent of the goal raised. A double number line is a graph that has two number lines with the same intervals indicated with tick marks. Each number line represents different data value. However, the data values are related to each other. In the graph shown, the bottom number line represents the percent of the homeroom goal, and the top number line represents the amount of money raised. Carla's homeroom has raised $240, which is 60% of their goal. You can see that indicated right here. So we are going to be creating some double number lines of our own to represent the goals of some other 6th grade homerooms. Let's skip over to page 425 and take a look at number 2. It says create Create double number lines to represent the goals of the other 6th grade homerooms using the information from the table. Write the equivalent dollar amount for each percent on the double number lines. I only want you to do letter A and letter B, so you are only going to be focusing on homeroom 6B for letter A and homeroom 6C for letter B. So go ahead and do those two with your group members. Let's take a look at the double number lines that you had to create. If you look first at letter A, this was the initial information that you were given from the table. The goal for homeroom 6B was $240. Now if I look over on this side of the double number line, 10% is going to be $24. So I should be able to see that each of those intervals are going to be going up by $24 for this double number line. I can do the same exact thing for letter B then as well for homeroom 6C. I was given $360 for the goal. So if that was 100%, I would know then that 10% of that 360 would be $36. So each of the dollar amounts are going up by 36 then on the double number line for letter B. If we turn to page 426 and take a look at problem number 4, this is going to be your homework for today. It says everyone loves a bargain. When you have a lot of shopping to do, every discount or sale helps reduce the amount of money spent. Sometimes this is called bargain shopping. So here you can see the table at the bottom of the page for the back to school sale with all of the items, the regular price, and the percentage off of those prices as well. I am going to have you do number 1 and number 2 on page 427 for homework. So refer back to this table, and this is something that we will discuss then tomorrow. That will do it for lesson 6.3 and determining the percent of a number. Please let me know if you have any questions. Thanks.